Hello, my name is Jake Hallam and this is my web-based image captioning tool. I've built this using Tensorflow.JS, and the original idea for this was implemented in Python on the TensorFlow image captioning with visual attention tutorial. And what I've done is effectively rebuild this from the ground up in JavaScript and trained it, and here it is demonstrated in a web browser. A huge amount of this has actually been re-implemented by me because a lot of the Python models and sort of trains libraries weren't compatible with the TensorFlow.JS, as I found. So a lot of those sort of fundamental mechanisms for automatic image captioning I had to rebuild. So you've got things like the attention heads, the decoder layers, the sequence embedding, all of that has been built now effectively from the ground up by me in JavaScript. So it's quite a complex project and it's really pushed me, but it's been fantastic, and I'm here to demonstrate it now and showcase some of these results. This would effectively be used by stock image photographers when they come back from a shoot, for example, and so they've got hundreds of different images and they don't necessarily want to go through and annotate each of those individually. It all runs completely on the front end, so there's no need for data to be sent to an external server, so you've got no privacy issues. Sort of if you've got a better computer, then obviously it will run quicker for you. And if this was in a business scenario, for example, you haven't got huge amounts of cost for running those servers. So what I'm going to do is just upload a few test images. Now these are effectively unseen images that I've picked from a stock website. So they're pretty random and of varied nature. There's a few here. Let's go with just the first 4 in my demo folder. So you've got things like people in the crowd, someone climbing, you've got a dog jumping into a lake or a puddle, and you've also got a guy driving a race car on a track. What I'm going to do is just hit generate captions. Now what this is going to do is send all of these images to a web worker. This project was built in React, so obviously that comes with a lot of memory overhead, so I thought it wasn't best to put the image captioning inference on the main thread, because obviously that's going to freeze the UI when you start trying to run this, and that's not great for users. So I put this on a web worker that effectively runs in a background thread, and it's a lot more performant. So let's have a go. I'm going to hit generate captions. And as you can see, it's pretty quick. It's less than a second per image, or even all 4 in just under a second, to be honest. So you've got a group of people are standing in a crowd. Now that's pretty accurate, I'd say. A man in a black shirt is climbing a rock wall. A black dog is jumping into a lake. Yeah, it's puddle lake, okay. A race car driver is driving on a track. So you can see it's fairly accurate. I'm not too sure how it's going to perform if you had, say, some very niche scenarios, such as like, I don't know, medical or space exploration or engineering type things, typically because that sort of thing isn't usually in the dataset. The dataset that I was using was the Flickr 8K dataset initially. I later pushed on and used the Flickr 30K just to add a little bit more variety. So what you'd do here is you would export these captions, or first you can even edit them. So say it's made a mistake, say that was a woman, for example, then you could change that there, and you would hit save on that, and you can just export those, and they will go down as a CSV file and that you can then go and import to your stock applications like Adobe Stock or Shutterstock or whatever you want to use. So that's the sort of workflow we've got going on here. Now let's put it to the test and see how it does on a large amount of images. So I'm going to go and clear all these out, and I think I've got about 25 different images on here. So let's just load those up. Here we go. So you've got everything from a dog sitting down here, those first few I put in there as well. You've got the sky sandboarding on a dune. It's pretty cool. You've got a snowboarder. I don't even know what that is, a jump or something. Little white dog over here. Alligator on a golf course. Lady walking a dog, and a surfer. So let's run this off and we'll see how it does. There we go, so it's already cracking on with them. In no particular order, you've got a dog is jumping into a pool. Okay, fair enough. You can already see some of the hallucinations and mistakes it's made, probably due to the size of the training data, which is relatively small. So you can see it's probably picking up this blue blanket under the dog as some water. So we've got a man is skiing in the sand. That's probably as close as we're going to get with a machine learning model to sandboarding. You got a snowboarder jumps over a ramp, very good. A man is sitting on a rock overlooking a river. So there's a little bit of grammatical misunderstanding that's going on. possibly also down to the training and conversions. It could be this is obviously a prototype for my university degree. Here we go. A group of people are sitting at a table eating food. Now that's probably got to be one of the best ones out of this batch, which I'm very happy with. Here we go. Here's a few other mistakes. So you've got a black dog is running on the grass. Now obviously we can see that's an alligator, and I think instinctually would pick up on the fact that that is not a dog. A surfer on a wave, so and a woman walking down a path with a tree branch in her hand, which isn't quite right. She's actually holding her dog. So you can obviously go in and edit that. So do something like with her dog, for example, and then just hit save. And then you can go and export all of those captions and download that CSV. That is effectively how this web-based machine learning model is going to work. So let's jump a little bit over to the code, and I'm not going to go too technical, but I am just going to show you the sort of core components that I've re-implemented in JavaScript from the original Python version. The captioning model. So this is based on the show, attend, and tell model, where you've got sequence embedding, you've got different attention heads within those decoder layers. It is largely based on code from the show, attend, and tell demonstration from Google. But obviously that is all written in Python, and there's a lot of abstraction going on there because you've got all of the Python libraries that are available that aren't necessarily available in Tensorflow.JS. So you can see I've got things like causal self-attention, cross-attention, my decoder layers and so on, all re-implemented in JavaScript. So it's been quite a lot of work, but it's paid off and it does work together. Of course, the training also had to be done in JavaScript because there's still some incompatibilities between the Python version of TensorFlow and Tensorflow.JS. So even using the TensorFlow.JS converter, I still had some issues with reloading it into TensorFlow.JS because of that deserialization process. I think there's some incompatibilities there, so that wasn't an option unfortunately either, which probably led to me, building this and developing this, which ultimately built on my understanding of how this model works. That brings me to the end of my demonstration. Thank you so much for listening. My name is Jake Hallam, and I hope you've enjoyed my web-based image captioning tool. I hope you have a great rest of your event, and I really hope to see you in the future.